Welcome back. Here in this video, I'm going to solve one question related to moment. This question is very helpful for 10th class, 11th class, 12th class students and the students who are also pursuing mechanical in BTech mechanical engineering and diploma in mechanical engineering students. So let's continue. Question says, determine the reactions at the supports. Supports here, beam is given which is having different loads. At this point 100 Newton load is acting in downward direction, 50 Newton is acting at point A in downward direction, and one special type of moment which is one special type of force distribution which is also distributed here in a triangular shape. It looks like the triangular shape. This is also known as uniformly distributed uniformly varying load, UVL. This is what uniformly varying load. It is also known as in short UVL. So UVL means uniformly varying load. Okay, so now its strength is 400 Newton per meter. It means what? Each and every meter distance 400 Newton force is acting in downward direction, and it varies. It varies as distance moved from left to right direction. The magnitude of the force will vary. Magnitude of the force is increasing. Now at a distance 2 meter far from this point, one uniformly distributed load of magnitude 300 Newton per meter is acting at from this point to this point, and one force is acting in upward direction, that is 30 Newton force, which is a point load. Okay, at this extreme point 30 Newton load is acting upward direction, and one of the extreme and 100 Newton force is acting in downward direction, and there are two supports, one at this point A and one another force another reaction at point B. So which we have to find here. So reaction force at point A and reaction force at point B, that is RA and RB, which we have to find. According to the question given, this is the case of beam and distributed load. Different types of load is acting at this point. So let's continue. First of all, I would like to say what will be the value of total amount of force that is acting in vertically downward direction for this uniformly varying load. See, if you say at this point, then how much amount of force is acting? 0 Newton force is acting, and at a distance 3 meter ahead, what will be the value of 400 Newton per meter? This is the intensity. So total amount of load for this distribution, total force will be equals to area of this triangle. Area of the triangle. What will be the area? What will be the value of area? Half into base. What will be the base? 3 meter. And what is the height? 400 Newton per meter. So meter goes cancel out. So 200 times 200 multiplied by 3, that is 600, and what will be the unit? Newton. So total force is nothing but the area of the triangle constituted by this uniformly varying load. So what value we have obtained? 600 Newton. And where it is acting, this force is acting at CG, center of gravity of this distributed load. Suppose somehow CG will act at a higher position distance, let us say it at this point, and what will be the net resultant? 600 Newton force is acting. Okay, 600 Newton force is acting, and at a distance from here and here, h by 3 distance, 2h by 3 distance, h by 3 distance and 2h by 3. H by 3 means what? From here 3 by 3, yani 1 meter distance, and from here it is saying 2 by 3 times h, so 2 meter. So CG will act from this point 2 meter and from this point 1 meter. Okay, so now we have obtained this much. So we find, first of all, beam is, since beam is in static equilibrium or equilibrium, therefore summation of all vertical forces would be equals to 0. So we can say, therefore this 100 Newton force is acting in downward direction. Let us say this downward acting force is taken as positive, and upward force is taken as negative. So we can say 100 and 50 Newton is also acting downward. 50 plus what will be the value of total force? 600 Newton acting in downward direction. So plus 600, and now 300 Newton per meter. It means what? Each and every meter distance 300 Newton magnitude. So what will be the value of total force? Total span is 3.5 meter, and each and every meter 300 Newton force is acting in downward direction. So total force would be 300 multiplied by 3.5. So plus, and it is acting in downward direction, hence I am taking as plus 300 multiplied by 3.5. And now one force 30 Newton is acting upward direction, so we can take minus 30. Another force RA which is also acting upward direction, and RB that will give 0 value. So we can calculate its value would be 100 plus 50 plus 600 plus 300 multiplied by 3.5 minus 30, 1770. So we can say up to this 1770 minus RA minus RB gives 0, or if we transpose these two forces into right hand side, then it becomes plus, which is equals to 1770. So can I say in direct way? So RA plus RB is equals to 1770. Let us say it is equation 1. Now we have obtained one equation and there are two unknown quantities, so second equation must be there so as to calculate the value of R and RB clearly. Okay, so now what we have to do here, there are two possible cases. At this support point A and at this support point B, either you can take moment about all the forces about this point A, or you can take either summation of all the moment about this point B and equate it to 0. Why? Because the beam is in equilibrium. So I am choosing the point B so as to calculate the value of moment or the unknown quantity RA is very easy. Okay, so now taking summation of all the moment about this point B and equate it to 0. Why? Because the beam is in equilibrium, so there is no rotation would take place for this forces. Okay, so now see, RA would produce at this point B. I am focusing the point B as a moment center, so RA will produce clockwise moment, see, in this direction clockwise moment, and remaining all the forces, say 100 Newton force is acting in will produce anti-clockwise, 50 Newton is producing anti-clockwise. This uniformly distributed which is having resultant is 600 Newton will act at this CG point and is producing anti-clockwise moment. This uniformly distributed load will also acting in downward direction, so that it produces anti-clockwise moment, and 30 Newton force is also producing anti-clockwise moment. So if I am taking anti-clockwise moment as a positive and clockwise moment as a negative, anti-clockwise moment is positive and clockwise moment is taken as negative. So we can say this producing anti-clockwise, see 100 Newton force, and what is the distance from this point or line of action and the point B? 1.5, 1, 3, 4 plus 2, 4 plus 2, 6, 6 plus 1, 3.5, 9.5 plus 1.5, 9, 1, 10, 1, 11. So we can say 100 into 11. And now 50 Newton plus 50 Newton multiplied by 1.5 meter ahead, this force is acting. So if I am subtracting 11 minus 1.5, then distance would be obtained. This also producing an anti-clockwise moment about this point B. Now 14600 Newton, which is also producing anti-clockwise moment and acting about this point CG. So what will be the distance? 1 plus 2 plus 3.5, because moment center is acting at this point. Moment center from this point and this point is what? 3.5 plus 2 plus 1, that is 2 plus 1, 3 and 3.5, that is 6.5. So we can say 600 into 6.5. And now uniformly distributed load having magnitude 300 multiplied by, so we can say 300 multiplied by 3.5. This is the magnitude of the total forces and acting 50% distance from this point. So we can say multiplied by 3.5 divided by 2. And now 300 is also acting, 300 is also 30 Newton is also producing anti-clockwise moments multiplied by 2. So 30 multiplied by 2, that will be equals to RA will produce anti-clockwise moment. See here, RA in this way it is acting, so we can say RA multiplied by what is the distance? See here, 3.5 plus 2, 5.5 plus 3, 8.5 plus 1, 9.5. So 9.5. If I am calculating, the value will obtain 1100 plus 50 times 1100 plus 50 times 11 minus 1.5 plus 600 multiplied by 6.5 plus 300 multiplied by 3.5 divided by 2, this plus 60, because I am taking square, 60, its value is 7372.5 equals to RA up multiplied by 9.5. We can say, if I am transposing this 9.5 into right hand side, it is multiplied, in left hand side it is multiplied though. So while transposing it will be divided. So we can say RA is nothing but 7372.5 divided by 9.5 divided by 9.5. So we have, therefore reaction at point A is 776.052 Newton. Once we get the once we got the value of RA, putting in equation 1 we have, so putting the value of RA in equation 1, we get RA, that is RB equals to 1770 minus RA. So 1770 minus RA value 776.052 Newton. Its value is 993.947 Newton. So we have got reaction force at point A. This is what? Reaction force at point A, and this is reaction force at point B. Now the question says we have to find the value of reaction force at point A and reaction force at point B, and 100 Newton, 50 Newton, 400 Newton, that is uniformly varying load, and 300 Newton per meter, that is uniformly distributed load, and 330 Newton, different types of forces acting at on this beam, and we have to find the value of reaction force at point A and reaction support at point B. So this is the way through which we have already calculated, and I think it is very easy. So to calculate the amount of force and the force acting acting at this point in uniformly distributed load. Once again I am going to show you. See, uniformly distributed load is in triangular shape. At this point, throughout the span length is 3 meter distance. Okay, so now at this point beam, 0 Newton force is acting, and as we move, then the value of force is increasing, and at this end 400 Newton per meter the intensity is given, maximum value intensity is given. So what will be the value of the total force acting if we convert it into uniformly distributed load? Then the amount, this amount will be added and this amount will be subtracted. So to calculate the value about this point, here we can say the total amount would be nothing but the area of the triangle, half into base, that is 3 meter, into distance. What is the perpendicular distance? 400 Newton per meter. See, it's a unit. If I am saying that meter and this meter is divided, so it can be cancelled out. So what will be the value total? So 400 multiplied by 3, 1200 divided by 2, 600, and unit would be Newton. Newton is left out. It means what? This indicates the total amount of force for uniformly varying load can be calculated by finding the area of the triangle constituted by the force or loading intensity and the base or span length. Okay, so where the amount of force 600 Newton is acting about the point CG, and as we calculated, CG of the triangle will be CG, center of gravity or centroid of the triangle would be let us say this is what total H. So maximum side CG will be acting in maximum mass side or maximum area side. So this would be here at this point CG is acting. So this value would be nothing but the 1/3 of the height. This distance is 1/3 of the height, means h by 3. So total amount is h. So this distance would be what? What will be the value? 2h by 3. So from this point CG is 2h by 3 distance, and from this point CG is h by 3 distance. We can say h by 3 distance from the from this side and 2h by 3 distance from this side. I hope it is very clear. So at the end, if you find my video very helpful, so please like, comment, subscribe my channel, and share it among your family and friends. Thank you for watching my video.